Hi everyone, today we will solve this elegant geometry question. It is from International Math Olympiad Shortlist 2023. We are given a cyclic quadrilateral ABCD and requiring the angle A is less than the angle D here, as you can see in this photo. And then we have M be the midpoint of the arc CD, here CD, but they are two arcs, one of them contains A. And in the question we are required to do it with the arc that doesn't contain A. So it will be this arc here, and M is the midpoint, so these two arcs are equal. Suppose that there is a point P inside ABCD, here P, such that the angle ADB is equal to the angle CPD. Angle ADB I will cut, and here alpha is equal to the angle CPD. It is also alpha plus beta, and the angle ADP is equal to the angle PCB. ADP, which is beta here, is equal to the angle PCB. It is also beta here. We are asked to prove that the lines AD, this line, then PM, this line here, and BC are concurrent. It means that all of these three lines intercept in the same point. From the first look, I felt the urge to connect AM and BM. We know that the arc MC is equal to the arc MD. That is why the angle here CBM, let's say it is theta, then it is equal to the angle DBM. Also same as for the angle A, or we can say the angle DAM, it is also theta here. Now we can see that, by the way, this angle is beta plus alpha. I guess I unintentionally deleted that. Here we see that this angle here will be sum of the CPD plus PDB, which is 2 alpha plus beta. And also same thing happened with this triangle here, one triangle overall. That is why the same angle here will also be 2 theta plus beta. It means that the angle A is equal to the angle theta. The degrees are same. That is why we can just use alpha here in this question. So I will change these parts also with alpha. Let's extend the line BC and AD. And then let's extend the line BM and AM as well. And let's also intercept them with BC's and AD's extensions, like this. Now let's call this point X and this point Y. Let's call this point here E and this point here F. And we know that the angle PEM is equal to the angle BEC, and these two angles is equal to 180 minus alpha plus beta. It is also the same thing for the PFM angle, so it means that these two angles are equal. And also by using these two angles we can see that the sum of the angle EPF plus the angle PEM is equal to 180 degrees. Also same as EPF and PFM. It means that the lines PE and FM are parallel. Also same as for the lines PD and EM. So we get here a parallelogram, and we will use it so much in this question. As you remember, we get y by extending BM and AD. That is why we can see that this angle here, BYA, will be equal to beta as well. Also, we can do the same thing and get that the angle BXA is equal to BCP, and it is also beta. Now, let's carefully analyze it. We see that in the quadrilateral BAYX, both the angles BXA and BYA subtend to the same edge, which is BA. Also, we know that the angles are equal. That is why we can say that the quadrilateral ABXY is a cyclic quadrilateral. Now, let's just change some angles here. Firstly, let me just connect these 2 points, X and Y. Here, in the cyclic quadrilateral ABXY, the angle BYX is equal to the angle BAX. Also, if we connect DM and CM, then we can see that the angle BAX is actually the same angle as BAM, and that is why the angle BAM, according to the cyclic quadrilateral ABCD, is equal to the angle BDM. And both the angles CBM and CDM subtend to the same arc. That is why the angle CDM will be alpha here. Also, the angle DCM. That is why we can say that the angle PDC is equal to the angle BDM. We know that the angle BDM, which is this angle here, I will just show it in green color. This angle here is equal to this angle, and also this angle BAX is equal to BYX. In the end of the day, we found that the angle PDC, this angle, let me show it with red color here. This angle here, PDC, is equal to the angle BYX, or we can say even MYX. Also, we know that PEMF is a parallelogram, and this angle should be beta plus alpha. That is why this angle here, which is XMY, is also beta plus alpha. We found that two angles in the triangles CPD and the triangle XMY are equal. It means that all angles in the triangles CPD and XMY are same. Let's carefully analyze this part. We know that the line that contains EM and PD, these two lines are parallel. That is why the angle PDC here will be equal to the angle here, this angle here. I'm showing it with red color. And also we know that the angle PDC is equal to BYX. It means that this red angle here is equal to BYX, and we found that CD is parallel to XY. Because of this, in the end of the day, we found that XY is parallel to CD, and then PC is parallel to MX and PD is parallel to MY. So we find that because of the parallel sides, we have homothety in the triangles PCD and MXY. So because of this reason, we know that the line PM, CX, which is also the line CB, and DY, same as AD, they are intercepting in the same point. So we can say that yes, indeed the lines PC, PM, and AD are concurrent.